y square equal to 4ax. This is the parabola given to us. Let me write question number 1. Given here, what is given to us? The curve, equation of the curve is parabola. This is y square equal to 4ax. This we know about. Y square equal to 4ax curve is given in line between the vertex 0, 0 and the lattice rectum. And the lattice rectum is revolved about the axis of x. So this curve from vertex to the lattice rectum is revolved around axis of x. So that solid will be obtained, a circular form will be obtained. Suppose the elementary part I have taken, then this a circle will be obtained, a very minor. If I take this parameter only, then parametric form and the circular solid circle will be obtained. The solid circle is extended from 0, 0 to a 0 to a x coordinate. Then total solid is obtained. So that volume will be declared. So the volume given by this case, let me write. Let me solve the equation here. So volume of the solid obtained after revolving the curve O. Let me take here, this is A point, let me take, this is C point, and this is A dash point. OA, curve OA, part of the curve OA, revolving the curve OA around OC, or the axis of x, OX axis, or around the axis of x, or OX. Okay, that solid will be obtained. So therefore, the volume is given by volume is equal to, here limits are x equal to 0 to a. Okay, here it is pi into y square into dx. But we have to convert this y into x coordinates, because this is with respect to, we are integrating with respect to x. So all the terms will be in x coordinate. We have to write that into x. So pi, let me take outside, this is constant. Y square is 4ax. Now this is 4a into x into dx here. So this is nothing but 4 pi into a constant. I've taken outside, this is 0 to a. Here it is x only into dx. So this is nothing but 4 pi into a. Now integration is x square upon 2, 0 to a. It will give us 4 into pi into a square upon 2. 2 to the 4. This is nothing but twice pi a cube. 2 pi a cube. Okay, this is twice pi a cube. Only twice pi a cube, because this, here it is a cube. Why? Because a square, from this, when we substitute the limit 0 to a, this is a cube. So a square into a, because a was already there. This is, and 2 to the 4, so twice pi a cube. This is the volume here. Cubic unit, we can write unit, but not required. Unit is not required here. This is twice pi into a cube. Cubic unit is the unit of the volume. So we can write, but no problem. Only we write this one. Cubic unit. Unit can be any meter, centimeter, or whatever. This is 2 pi a cube answer. Answer of this equation is 2 pi a cube. Volume of the solid obtained by revolving that in around the axis of x. So that's the volume here. This is the answer. Finally, this is the answer. 2 pi a cube. All right. This is question number 1. Now let me talk about question number 2. Now question number 2. What did we talk about? Let me take the question number 2. Now second question says that a paraboloid of revolution is generated by rotating the parabola this about OX, means axis of X. So find the volume generated by that action of the curve which lies between x equal to 0 and x equal to h. Okay, first thing is this. And if R is the area of the cross section at x equal to h, right, then so that the volume is a half that of a cylinder of base area R and length h. What is the volume of a cylinder? We know about volume of cylinder is pi r square h, or r square is the radius. Okay, that is the point. First thing is that we have to find out what is the volume of the paraboloid. Okay, that we just calculated. It was 2 pi aq. If it is a here, yeah, it is a here. Then we have to calculate in case if it is h, sorry, between 0 to h here. Let me calculate what is the volume of the paraboloid. Okay. The paraboloid of revolution is generated by rotating the parabola. Y square equal to 4ax here. Y square equal to 4ax. Again, this is the paraboloid. Okay, this is parabola here. Paraboloid. And it says that at x equal to h. Now this is not red. Okay, here x equal to h here. X equal to h here. Now it says that R is the area of the cross section at x equal to h. Now so that the volume is a half that of the cylinder of base area R and length this. Now okay. Alright, so this is the minor axis, the mean. Okay, that is another point. So let me first take that what is this kind of question here. Okay, so first thing is that when a paraboloid volume, the paraboloid of revolution is generated by rotating the parabola y is equal to 4ax around the axis of x or OX. This is y dash x dash. Okay. Now again this is OA. Let me take a point here again. This is C point, center point. And up to this point this is h and 0, and this is 0 0. Now it says that paraboloid is obtained by revolving. It says y is equal to 4ax and OX. Find the volume generated by that action of the curve which lies between x equal to 0 and x equal to h. Okay, x 0 to x equal to h. Let me find out what is the volume. So solution. Here volume. Let me write volume of the solid generated by revolving the paraboloid, generated by rotating the parabola. Okay, by revolving the parabola, this arc of the parabola OA around OX or x-axis, OX or axis of x between x equal to 0 to x equal to h is given by pi into y square into dx. This is 0 to h here. It is pi into, now y square is in this case again 4ax, 0 to h into dx. H. I have to integrate this to pi into, let me take 4 pi a outside. This is h square upon 2 again, 0 to h. So the volume will be 2 into 2 to 4, 2 pi into a into h square. Try to understand. This is h square here because in place of x we have to put h. This is the volume of that figure. Now this volume, now R says, what is the R here? Now R is equal to, R is the area Okay, R is the area. R equal to is the area. Okay, R is the area. Okay, the area of the cross section or the area of the cross section at x equal to h. At x equal to h. If I just take at x equal to h here, at x equal to h here, so cross section at area, the base of this is, so this is the area here. So that will be, let me take here AC, this point is OC or something, so OC square, sorry, this AC square. AC square is the radius of this cross section. So the radius will be AC square. Okay, that we have to talk about. That is nothing but y coordinate of A, that is again 4AH, 4AX here. So this AC square is equal to here y square, because y coordinate of this is x and y, let me take. So this height is y here of coordinate A, and AC square, which says okay, h here, it says that AC square is the, okay, this says action of the curve which lies between x0 and R is the area of the cross section at x equal to h. At x equal to h, the cross section is obtained, and so that the volume is half that of the cylinder of the base. Now the volume we have to find out in this case. So the same volume is, I think, obtained. This volume, this volume same, because AC square in this case is y square, so the same value will be obtained. So volume will be, so volume of this cross section, volume of the cross section, the solid obtained by this cross section, okay, revolving around the axis of x between 0 to h, that will be the volume of the cross section. Cross section is equal to again 0 to h, or this is AC square into dx here, pi into AC square. It is nothing but pi into AC square is y square, 0 to h, and this is y square into dx, and y square is again 4ah we have to put. This is nothing but 4ah. Okay, it's 4ah square. So this is pi into y square. First is 4ax, but in place of x, you will write here this is x square integration upon 2. Okay, this is again 0 to h. In place of x, we have to substitute h here. So this is x equal to h here. So in place of h, we can substitute this. This is nothing but twice pi into a, 2 to 4 into h square. Now we can write it as, let me now write it as half of the, it says area of the cross section at x, so that the volume is half that of a cylinder of base area. Now this is the volume here. Now this volume can be written as half, if I write 4 into pi into a, okay, 4 into pi into a into h square, or if I take okay, that volume was, initially the volume was 2 pi a square, so this is 4 pi a, half of the volume, this volume equal to 4 into pi into r square or h square into h, pi a square into h. Now let me just write, because this I have to just convert. H square is h, to one h I have to take inside, and second h I have to write outside, and this will be 4 times, because 2 I have divided, it is 4 pi a into h square, okay, into h square into h, or if I take a outside, so it will be a into h square, 4 pi r square into h. The volume is of cylinder. What is it? Now it says the half of the okay, the volume is the half that of a cylinder of base area r. Base area, okay, area is pi r square. This pi r square is Okay, pi r square means pi into h square. That was the area here. So that is r square. So r square was pi r square. Okay, so 4 pi into, this is 4 pi r square means h square. Here we have taken h, the height of this, and radius. If I take the, okay, the radius is h here in this case, so h square is okay, and a I have to take outside, and 1a inside. Half of the volume of the cylinder is, volume cylinder is pi r square into h. Now this is h here we have to write, because volume of the, no, this is area, we have to write here 4 times 4 pi r square. This is the volume of the cylinder, 4 by 3 pi r square. Just let me think about what does it talk about. A parabola of revolution is generated by rotating the parabola by square equal to 4ax about ox. Now find the volume generated by that action of the curve which lies between axis 0 and axis 0. That we have done. Okay, that was 2 pi a square into h. It was pi h square, 2 pi a into h square. That was okay. Now if r is the area of the cross section at x equal to h, now show that the volume is half that of a cylinder. Volume is okay. Now in this case volume we have calculated. Volume is 2 pi a into h square. The same thing that we have done here. So 2 pi into a h square. That was the volume here. Okay, now let me just think about it. What does it mean? Now in this case 4 pi a into h, and 4 pi a h. So this is one of the r into h. So r by 4 pi a h. Okay, 4 pi a h is the r here. So h square is 4 pi 4 ah. Okay, that means this is the point here. That area of the base is, if I take radius r, pi r square, this is pi into 4ah, but 4ax in place of x we have to put here h. R is 4ah. Try to understand. Okay, so this can be written as 4 into pi a into h, 4 pi, this pi we have taken outside. Let me take here pi outside. So here pi into r square means 4ah. So pi will be inside this 1.2. It is 4 into pi into a into h, and 1 h outside. Sorry, 1 h outside, not h square, but 1 h outside. Now this is okay. So this can be replaced by this 2 pi ah square we were getting. But in this case, this 4ah is the r square. But the r square is the y square in place of area. Pi by square, that means pi r square. Pi r square is this, but the volume operand is this. Now this is 4 pi ah. This is the area of the base here. 4 pi ah. So this is half of the volume. This is area of the base into h. Okay, this is the volume of the cylinder. This is how we have obtained. So volume equal to this volume, which was 2 pi ah square, can be written like this. Now this is 4 pi h, which is pi r square. Sorry, this is pi r square here. 4ah is 4 pi h. This is 4 pi into ah. Now this is r square, area of the base. This is half into r square into h. This is not the same thing. Area of the base r square into h. R square is 4 pi ah, which we have just calculated. And since it's proved, it says that this is volume of the cylinder. R square into h. Pi r square into h is this. Okay, we could take here, this is r square into h, area of the base. So the volume of the base cylinder. What does it say? That the, so that the volume is half. This volume plus 2 pi ah square is written like this, 1.24 pi ah into h. But 4 pi ah is r square, area of the base, into h. Pi r square h is the volume, area of the volume. So we can write this. This is 4 pi ah. volume is half that of a cylinder of base area R. Base area R, we have taken R square is the area here. Okay, so R is 4 pi AH. This 4 pi AH is the area of the base. And length H and length is H. So R square into H. Right, area of the base. Suppose R is area, which is given by 4 pi AH that we have already calculated. So R square into H, the same thing. This is volume of the cylinder. Half of the volume of the cylinder. R square H, that means right here. R square H, the area of the base into length H. This is a volume of the cylinder. This is volume of the cylinder. Alright, that is the point here. R square is given by 4AH because it was 4AX. Y square equal to 4AX. Y square, if I write R square, that means 4AH in terms of H. This is the solution. I mean, volume is half of the volume of the cylinder. R square H is the volume of the cylinder, but R square is the area into width or into height H. In this case, it is length here, length or width or height, the same thing. Area of the base into height. This is the volume of the cylinder. So half of the volume of the cylinder is the volume of this solid, which is obtained by cross section of base H revolving around axis of X. This is the question number 2 we have done. Now let me talk about question number 3. Question number 3 is also of the similar category. I mean, very tricky one. As when I was writing down then I was thinking that this question is also very tricky. Now question number 3. Let me check what does it say. Now question 3 says, prove that the volume of the solid generated by revolution of an ellipse round its minor axis. Try to understand. Around its minor axis is a mean proportional between those generated by the revolution of the ellipse and of the auxiliary circle about the major axis. First, I have to find out that what is the volume of the ellipse. In this case, ellipse. Let me take the equation of ellipse. Where equation of the ellipse, minor axis, major axis, let me define. Now this is the ellipse here I have taken. Okay. Now this is the major axis. X-axis is the major axis. O origin. X dash axis. This is Y and Y dash axis. Now this is B point. Let me take. This is A here. This point is A0. This is minus A0. We know about. Okay, and if I take elementary strip here, this is one quadrature. And if I have to find out by revolving this around the minor axis is this axis. OY is the, or this is B point, let me take. B point is 0B. This is B dash here. This is 0 minus B. And here it is A0. Okay, so if I revolve this curve around the axis of B, or this curve around this whole Y axis, then limits B minus B to plus B. Total solid is obtained by revolving ellipse around the minor axis. What is the volume obtained by revolving the ellipse around the Y axis? Sorry, around the minor axis. Minor axis, Y axis here. So B we have taken minor. What is the minor here? X square, equation of the ellipse. X square upon A square plus Y square upon B square equal to 1. Let me write here properly. Y square upon B square equal to 1. This is the equation of the ellipse we have taken. Here, axis of X is the major axis and axis of Y is the minor axis we have taken. Okay, so the volume of the solid generated or obtained by revolving the ellipse around the axis of a minor axis, you may say minor axis, that is y axis, minor axis or y axis in this case. What is the volume then in that situation? It will be volume will be pi into x square, because it is y axis, around the y axis, into d by, limits are here minus b to plus b, around the y axis, okay, and here pi into x square. Now x is also to be converted into y in terms of y here. So from this equation, if I take x square equal to, now from the equation of this, let me write x square upon a square is equal to 1 minus y square upon b square. So this is b square minus y square upon b square. So x square equal to a square upon b square. In bracket it is b square minus y square. Or here x equal to, therefore a upon b square root of b square minus y square. Okay, this is the value of x. X square is this value. Therefore, this is nothing but minus b to plus b, limits here, and pi, let me take outside. X square is this value, a upon b under root, this is b square minus y square, okay, into d by. Now let me write it as twice pi by definite integral formula, property of definite integrals. If it is minus b to plus b, it will be twice pi 0 to b, we can write. And this is a upon b, twice pi into a upon b. This a upon b I have taken outside. The square root of b square minus y square into d by. Putting here, let me solve it. Putting y equal to b sin theta, let me take b sin theta in this case. So d by, therefore differentiating it with respect to theta, we get b into cos theta into d theta. What are the limits here? Let me put the limits. At y equal to b upper limit, this b, and 0 is lower limit. At y equal to b, sin theta equal to 1 or theta equal to pi by 2. And at y equal to 0, theta equal to 0. Why? If I put y 0, then sin theta equal to 0. Sin theta 0 is for sin 0. Sin 0 degree is 0. So theta equal to 0. And when y is b here, b upon b is 1. So sin theta is 1. Sin theta 1 is for sin pi by 2. So theta equal to pi by 2. Okay, so limits are here. Now let me find out what is the now volume of this. So therefore, so volume we are calculating. This is the volume here. Let me take, this is v volume v here is twice of pi into a upon b. Now it is b sin theta d theta. Okay, it will be 0 to pi by 2. Let me write. Under root will be b square minus b square sin square theta, inside the square root sign, and outside d by is b cos theta d theta. Try to understand. Now then what it will be? Twice pi a into b. This b and this b outside. Out of this b will come out. This b and this b square will be pi into b square upon b. One b cancelled out. Twice pi ab, okay, 0 to pi. Now this will be 1 minus sin square theta is cos square theta, out of square root is cos theta only. So cos theta and this cos theta is cos square theta d theta. Now what is the final value? Let me now find the final solution of this. Now it will give us twice pi into ab cos square theta, when theta, sorry, this is pi by 2, I'm sorry, limit is pi by 0 to pi by 2. then it is 1.2 into pi by 2 by reduction formula. You know this. Okay, so this is here pi into x square we have taken. Again, 1 pi more has come out. 1.2 into pi by 2. So it is 2 to the 4, 1 to cancel out. So it is pi square. I'm sorry, this is a into b upon 2. Pi square is coming because area of this will be pi into y square in this case. Pi was outside and y square will be put here, and 0 to pi by 2. This is cos square theta because cos theta and cos theta is cos square theta. And that will be by reduction from the 0 to pi by 2 limits is there. It is 1.2 into pi by 2. This we know about. Okay, this is pi square into AB upon 2. This is the volume V. First volume is pi square into A into B here. Looking something strange. Okay, no problem. This is value of V. First volume of the minor axis when the ellipse is revolved around the minor axis. Then we obtain this minus V2 plus V and pi into cos square, pi into y square. Okay, pi into, sorry, x square in this case. X square was in terms of y. That was here, pi upon b. Okay, so that is the point. Now let me take the second point. It says that the auxiliary circle will be x square by square equal to a square. We will take x square by square equal to a square. We will take here in the auxiliary circle. Okay, so that is okay. Now in this case, the volume of the cylinder is 4 by 3 because solid that's obtained will be the figure of that point here. Now in this case, it is not 4 by pi square AB upon this, but volume of an ellipse obtained in this way is nothing but b square upon a square we took. Why b square upon a square we had not taken? I'm sorry, it was b square upon a square. I've taken it wrongly. Something I was just thinking about and how this value is obtained. This is pi into y square, but pi into a square into b square. I'm sorry,